So this is lesson 1.1 on solving equations, and our EQ is how do you solve an equation in one variable. So what that means is we're solving an equation that has one letter in it, like just an M or just an X. But there might be multiple steps to getting that solved. We're going to look at some vocabulary first. So the definition of an equation is it's a mathematical sentence that uses an equal sign to show that two expressions are equivalent. All right, so you have an expression on the left, you have an expression on the right, and then you have an equal sign in the middle to show that they are equal to one another. All equations have equal signs. The solution of an equation is a value for the variable that makes the equation true. All right, so if you substitute that value into the equation, you get a true equality statement. The left side will equal the right side. And then there's pieces to the equation that we kind of have names for. So here's an equation breakdown for you where we have the equation 3x plus 5 equals 20. And so the whole thing is an equation because it has the left and the right side and an equal sign in the middle. Now, if you just look at one side, that is an expression. So 3x plus 5 is an expression. So is 20. 20 is an expression. The pieces that are added together are called terms. 3x is a term. 5 is a term. 20 is also a term. When you have a term that has a variable in it, the variable is the letter, and the number that touches the variable, that's called the coefficient. So 3 is our coefficient, our variable is x. 5 and 20 are terms, but they're different types of terms. They're called constants, which means they are just numbers, okay? There's no variable part to them. Okay, so I want you to think back to when you were in 8th grade and you were learning about this stuff. The equation 3x plus 5 equals 20. I want you to go ahead and try and solve that. Okay, so this is an interactive slide. So you're going to be over in your Pear Deck tab. And you have tools to draw with, you have tools to type with, and you're going to solve 3x plus 5 equals 20. I'm going to give you a few minutes to do this. Yours isn't loading, Bree. Maybe try closing out just the other two tabs that you don't need. Just leave the Meet and the Pear Deck tab open. That might help. You might even try refreshing your screen. Chromebook has a refresh tab, or you can use the one. Yay, there it went. Yeah, sometimes Things will be slow. It helps if you close out any extra tabs or maybe just refresh it. Okay. So I do want to start sharing some of your screens so you guys can see what people are doing, especially if you're kind of stuck and don't know where to begin. So this person here wrote that we're going to take 20 and we're going to subtract 5 from it to get 15, and then we're going to divide 15 by 3 to get 5, so x equals 5. This is absolutely correct. The work that they're showing here, this is more about like maybe using some mental math to figure it out. Ooh, look at this one. This one's cool. They typed it out. They drew a line coming down. They subtracted 5 from both sides. I like that a lot. And then they're still working on it. So 3x equals 15. And they're going to keep moving on. That's a really nice organized way to do your work on here. So they're using that line tool and the text typing tool. Some of you have nice writing with the mouse. Some of you it's a little bit tough. Here they worked it out. 3x plus 5 equals 20. They're showing they're doing the same thing to both sides, all the way down until x equals 5. Very nice. All right, so so you're giving your reasoning behind it. Okay, so there's lots of ways to kind of show your thought process. This one's cool. So they kind of just, you know, did it by hand. They drew the line coming down, which is something I taught a lot of my students last year, like box and walls, a method where you put a little box around your variable, and then you have a wall coming down. And subtracting 5 and then dividing both sides by 3 and get x equals 5. All right, so we're doing really good on that. So what gives us the ability to do something to the equation on both sides like that is from properties of equality, right? And there's 4 of them here that we use when we solve equations. We have the addition property of equality, the subtraction property of equality, the multiplication property of equality, and the division property of equality, which basically says if you have an operation, one of those 4 operations, and you do that to the left side and then you do that to the right side, you're going to end up with a true statement. That's okay to do. There's 2 columns. So you have a column of examples, so with numbers. So if you started with the equation 3 equals 3, and then you did the same thing to both sides. You added 2 to the left and to the right. Well, that simplifies to 5 equals 5. It's still a true statement. And then it shows you examples going through with subtraction, multiplication, and division. That's a very specific example. There's a general way of writing it in algebra using the letters, and the only one that you're restricted on is the last one for division. You just have to make sure that when you divide both sides of an equation by something that you're not dividing by 0. That's really important. We can't divide by 0 in math. So here's an example using properties of equality. We're going to solve 3x minus 2 equals 6. So, and some of you guys are doing this on that problem where you had a chance to write on it. They're showing that by the addition property of equality, I can take 3x minus 2 equals 6 and then add 2 to the left side and add 2 to the right side. I'm doing the same thing to both sides of the equation, so I get a true statement. This gets simplified by combining like terms. Negative 2 plus 2 is 0, so I'm just left with 3x. 6 plus 2 is 8. And now we're going to use the division property of equality. I want to divide both sides. And the reason I'm dividing by 3 in this example is because I want the coefficient of the x term to become 1. So you have to think, what do you divide 3 by so that you get 1? Well, you divide a number by itself. 3 divided by 3 is 1, 1x. 8 divided by 3 is 8/3. When the coefficient of a variable is 1, you could write 1 there, but you don't have to write a 1 there, right? It's like an invisible 1. It's implied that it's there. So this next slide is another interactive slide for you. It's a click and drag slide. So we have an equation, 1/2 z plus 4 equals 10. You're going to use the subtraction property of equality. So you're going to subtract something from both sides of the equation. And you can see there's 2 boxes on this first row because you're going to drag down at the bottom. You will see there's a red 4, an orange 4, a yellow 6, and a green 6. You're going to drag 2 numbers into those first 2 boxes that make sense for the subtraction property of equality. What would I want to subtract from both sides? What's going to help me solve this equation? Do I want to subtract 4 from both sides? Do I want to subtract 6 from both sides? Do I want to subtract a 4 on the left and a 6 on the right? 6 on the left, a 4 on the right? There's different options. So you're going to drag what you think goes where. After that, you're going to combine like terms. So we have 1/2 z equals. You're going to drag something into this box. And then the very last box, you're going to drag something into. All right, there's 4 empty boxes. There are 4 numbers at the bottom. Go ahead and drag those numbers into the boxes where you think they go. This is an interactive slide, so you're going to need to go to your Pear Deck slide tab, your Pear Deck tab. That's what I'm trying to say. All right, so those of you, you should be back on the tab for Pear Deck, and you should be clicking and dragging. There's one correct way to put all those numbers in that'll make sense. All right, I found somebody who did it correctly. I'm going to go ahead and share with you their screen. So Caleb, go back to your Pear Deck slide because I'm going to share your work because you did it correctly. Okay, so here's Caleb's slide, and he chose to drag in the 4s in the first 2 boxes. And this is correct. We want to have the same number on both sides. And by choosing to put 4 here, 4 minus 4 of these combine to give us 0, and that goes away, and I'm just left with the 1/2 z. All right, and then 10 minus 4 is 6. And then from this step, it looks like we're multiplying both sides by 2. So 2 times 6 is 12. All right, so that's exactly what you wanted to do. And I learned this in my last class. If I try to show everyone's responses, it's very messy looking. It doesn't look very pretty. It's hard to tell what it shows. But yeah. Okay, moving on. Slide 7. All right, here's a word problem. Guys, look, word problems. This is about an ostrich and a kiwi. And we have a picture of an ostrich and a picture of a kiwi. So an ostrich is 108 inches tall. And that is 20 inches taller than 4 times the height of a kiwi. What is the height of a kiwi in inches? So when we talk about kiwi, we're talking about the bird that you see there, not the fruit. It's a kiwi bird. So we're going to take all the stuff. I put those pink boxes around important information, okay, because from that we have to be able to write an equation. The unknown thing, our question is the height of a kiwi, so we want to set that equal to a variable. K for kiwi works. The height of a kiwi is K. And then we're going back to this, the sentence. An ostrich that is 108 inches tall. When you see the word is in a word problem, typically means that's where your equal sign is going. Is the equal sign. So is 108 inches tall? What is 108? 20 inches taller than 4 times the height of a kiwi is. So that's why 108 is on one side of the equation on the left by itself, then the equal sign. And then 20 plus 4K comes from 20 inches taller than, more than, that's addition, 4 times, that's multiplication, the height of a kiwi is our unknown, our K. All right, so you guys are going to solve this equation now. All right, you're going to show your work in the large box and put your answer in the yellow box. I'm going to give you a few minutes to get this done. David, you could try leaving the meet, coming back. I'll post a video that you'll be able to go back and listen to it with sound later. See, more students are taking the option of typing it out this time, which is fine. It's not necessary. You can, though. I'm kind of looking at your screens as you're doing this. A lot of you are off to a great start. Esmeralda, nice work. You have the answer correct. Caleb, you have the answer correct. Bree, you have the answer correct. Nice job. Alexis, you want to go back and check some of your calculations? Raina, good work. You have it correct. Scott, you have it correct. Okay, so for just the fact that we're getting close to the end of the class, I'm going to go ahead and show you the correct solution. Okay, so starting with 108 equals 20 plus 4k, if I subtract 20 from both sides of my equation, I end up with 88 equals 4k. If I then divide both sides of my equation by 4, I end up with 22 equals k. So that means that since k is the height of the kiwi is 22 inches tall, right? And that is the end of the lesson. I'll put a video up